All right, welcome to our 1.5, 1.6 review. I'm just going to go over the non-matching part. So let's start off with our first question. I want to name 3 points on the plane P. There's P, and it looks like P is this rectangle right there, that plane. So this is a plane, a flat surface, two-dimensional. And the 3 points that are inside my red border look like it's A, B, and then down in that corner there is point C. So there's plane P, named by 3 points. Now I'm going to look at plane O. That's a typo, so on yours it should have said O. It might say N still. So I'm going to outline plane O just to make sure. So there's plane O. So here's plane O. And I want to give another name. So if I'm naming a plane, I need 3 non-collinear points. And that just means 3 points that are not on the same line. So non-collinear, not on the same line. So let's see, 3 non-collinear points. And that's going to be in my red rectangle there. The only 3 points I've got are A, B, and D. So if you want to, you can write plane ABD, or you could just leave it as ABD. I'm not going to be that picky. Technically, we would want plane ABD. So I'd want you to put the word plane. You could also have plane, DBA, or plane ADB. As long as you've got those 3 letters, that's all that matters. All right, now let's look for our intersection of plane P. I'm going to outline plane P again. So here's my outline of plane P, and I'll pick a different color. Let's do blue for plane O. So I'm looking for where plane P and plane O intersect. So kind of hard to tell there. But if we look at where they touch, so this should probably be, if we're being fair here, this should probably be dotted. So I got solid and then dotted, just to show that it's behind. So where they're touching at these corners, that pivot point, that's here and here, and that is line AB or BA. So you could name it line AB, line BA, or you could write out the word line AB or line BA. So that's my intersection point. So these 2 planes are meeting right here, right on this intersection line. Let's look at some more planes. So number 12, I'm going to name 3 collinear points. Let's just remember what collinear means. So collinear means they're on the same line. So I gotta find 3 points that are in a straight line, and I found 3 right there. So C, J, and B are all on a straight line. And now let's look at B. I'm gonna skip some of these, but I want to give a good explanation of B. So they want me to give a name for the plane that is the top of the box. So I'm just going to look at the top of the box, see what letters I've got to work with. And I want to give a name. Like we said earlier, I need 3 non-collinear, which means not on the same line. 3 non-collinear points, which means I can't use C, J, and B. Those are on the same line. So C, J, and B, that's not going to work. Well, neither would B, K, and A. But if I wanted to, I could pick to name my plane, I could pick C and J, and then I could pick G. That would work because C, J, and G do not form a straight line. They've got that 90-degree angle. So that's one way to name your plane. Or I could use C and J and A, or C and J and K, or K, G, A. All of those would work. So this is just one of many names you could give the plane. So I would pause the video here, see if you can get C, D, and E, and then I'm going to fill out my work in just a second. So left side of the box should be plane. I'll use HDJ. That would work, one of many names. And the intersection of plane AFE and plane BGK so I'm seeing where are these two planes touching. Well, they're touching at AG. Line AG. And then our last question, JC and JB, those would be opposite rays because they start from the same point and they go in opposite directions. So let's look at 13, 14, and 15. I want to write an equation for the segment addition postulate. So this would be, AB plus BC equals AC, or part plus part equals whole. So we can just go left to right and say FG plus GH, the other part, gets me my whole segment of FH. And similarly, we could do 14. Actually, I wrote it down, so let me just pull that down here. That one really would be AB plus BC gets me the whole segment. And then if I want to solve for x, so AC is 79. Let me move this over to show why I want you guys to use this. Because once you have that segment addition postulate, you can just fill in the numbers. AB is 4x minus 8. And another value for BC is a positive x plus 17. And AC is 79. So I could set this up and solve for x, combine my like terms. So 5x plus 9 is 79, or x is 14. All right, midpoint and distance formulas. I've got, find the average of my x's, find the average of my y's, doesn't really matter the order for midpoint. So this would be, let's see, 12 plus 23 over 2, and 3 plus 63 over 2. So my final answer would be see, 35 is 17 and a half. Oh, wow. Ran out of room there. 17 and a half, comma. And then my other point at 66, that would be 33. So there's my midpoint. And now we got to do our distance formula. So distance formula, I should probably write it like this. There we go. That's where I got x2 minus x1 squared plus y2 minus y1 squared. And it does not matter what order you choose. I'm going to give myself some more room here. So I could make 12 and 3 my x1, y1, or I could make 23 and 63 my x1 and y1. Really doesn't matter. I'm going to fill this out as square root of, let's say 63 minus 3 squared, and that would be my y's. So 63 minus 3 squared and 23 minus 12 squared. So then I've got the square root of 23 minus 12 would get me 11, and 63 minus 3 would get me 60. So I'll do both parts here. This is the square root of 11 squared is 121, and 60 squared is 3,600. And if you type that into a calculator, you should get 61 as your final answer. All right, I'm going to give you some time for 17. Just pause the video and then unpause it when you're ready. Check your answers. So I've got obtuse, acute, right angle, and a straight angle. Straight line, straight angle, 180 degrees. And now in 18 through 20, we're given, this is our angle addition postulate. So just like our segment addition postulate, you could write out, XYW plus WYZ. So part plus part to get the whole angle of XYZ. And again, XYZ, I want the whole angle. So you could write out that segment addition postulate, or you could just add up the two pieces to get 57 degrees. But the reason why I want you to write out the segment addition postulate, or angle addition postulate rather, is for problems like this, where you can write out all three parts and then just plug in the known values. So TPS is 48. RPS is 77. And then I can just plug in a variable for RPT because I don't know that yet. And my final answer would be 29 degrees. And over here in 20, I've got if the angle is bisected. Now we got to think about what bisected means. So bisected, that means to cut it into two equal pieces. So if it's equal pieces, then these should be equal expressions. So 3x plus 36 should be equal to 9x minus 14. And then 6x is 50, and x is 8.3 repeating. All right, I'm going to go through 21 and 22. I'm going to leave the last 4 for you guys to check, just to keep this video, I know it's already long, but from going any longer than it really needs to. So I'm going to classify these angles here as a linear pair or vertical, then I'll solve. So here I see they form a straight line. So RSQ and PSQ form a straight line. They are a pair that form a line. So they are a linear pair. All right, and this is 11x and this is 5x plus 20. So if they're a linear pair, if they form a straight line, then I got to think about what a straight line equals. So I have my segment addition postulate. I could write out PSQ plus angle RSQ would get me angle PSR. And I know that whole angle is 180. So I got 16x is 160, or x is 10. And then 22, let's trace our angles here. Here are my angles. They form an x, or 2 v's. So you can almost see there's a sideways letter V. There's a sideways letter V, so vertical angles. And if they're across from each other, if they're vertical, then they must be equal. That's one of our theorems. So 2 plus 3x must be equal to 62. Or 3x is 60, which means that x must be 20. And I'm going to cut it here. I know this is already a long video. Try to keep it short, or as short as possible. If you do have any questions, find me in office hours, and I will see you guys tomorrow.